Welcome to the Apron Academy. This video is specially designed for the dietitian in training, also known as the RD-to-be. In this video, we're talking about vitamin D, and this one is really awesome. I've talked about how I just love the fat-soluble vitamins, but this one is the only vitamin we can synthesize ourselves just by sitting in the sun. So that UV light can cause our bodies to synthesize vitamin D ourselves. So here's some little pictures. So vitamin D is derived from a steroid. So if we add on, close this ring, then that's a steroid. But the ring is open. So it's a psychosteroid. This vitamin D2, ergocalciferol, we find foods we find in this form include phytoplankton, yeast, and shiitake mushrooms, so really not a whole lot. But then this cholecalciferol, vitamin D3, that's our UV radiation. We get it from liver, eggs, fatty fish, and then some foods are fortified with vitamin D, and it's in this form. So like fortified milk, fortified yogurt, cheese, and even you'll see many of the supplements in this form. And now I do want to talk about how we can make our own. But should I do that in a sec? I think I may do that in a second. First I guess I'll talk about the absorption because it's just like all the other fat-soluble vitamins. We get it from our diet, then absorb it with our micelles. It's able to enter into the enterocytes, then incorporate it into the chylomicron, etc. So lipoprotein lipase acts on the chylomicron so that vitamin D is taken up into the adipose tissue. But again, it's not very accessible when it is in the adipose tissue. Any remaining vitamin D that's not taken up into adipose tissue is incorporated into the chylomicron remnant and then taken up by the liver. So we do have higher amounts of vitamin D in our liver. And since we do get vitamin D in our diet as well as in the skin, and I guess I should mention, so vitamin D3 diffuses from the skin into our blood, and then I guess I should go back all the way. Okay, so when we make our own vitamin D, we get it from the sun. We have our cholesterol. So imagine a cholesterol molecule. Then it's changed into 7-dehydrocholesterol. So this is found in our skin, and it forms a layer on top of our skin. So when the UV rays act on that 7-dehydrocholesterol, these UV rays help it to produce pre-vitamin D, which then is converted into vitamin D3. However, that's still not the active form, but I'll get to that in just a second. But vitamin D3 that diffuses from the skin goes straight into the blood. So in the blood, vitamin D3 is bound to vitamin D binding protein, so VDBP, and that is different from the fat absorption. So just for when we get it through our skin, it is different from the fat absorption. And we don't get toxic effects from UV generated vitamin D3 because we have other things that we're making too, things like lumisterol, tachysterol, so we don't have any toxic effects from vitamin D3 that's coming from the sun. Okay, now there is our absorption via the skin and through our diet. But since that distribution is different of how it comes in, so like through the skin, it goes straight into the blood and then does that. Through the diet, it goes through that typical fat-soluble vitamin absorption. Even though it's different, they eventually do end up in the liver. So let me show you a picture of that. So these are two separate things, and actually what I kind of want to do is I'm going to separate them. They're basically the same picture, but let's look at them separately before we confuse ourselves. So this is what I just talked about. So the skin, we make the 7-dehydrocholesterol. UV light hits it. It's able to make pre-vitamin D3 and then vitamin D3. In our diet, it's able to go through that fat-soluble vitamin absorption, and then we end up with vitamin D3. So vitamin D3 is then hydroxylated, and we have 25 OHD. This is in our liver. It's hydroxylated again, and then we have, 125 OHD, which is our calcitriol. So that's in the kidneys, and this is our active form. It's the functional form of vitamin D. It's regulated by the parathyroid hormone that responds to declining calcium, and it causes a release of calcium from bone and increased synthesis and absorption from the kidney and intestines. So, still not, and this picture is just a bigger picture of this part. So I don't want to move on. The vitamin D3, still not in that active form yet, has to be hydroxylated, circulates in the blood as complex with that VDBP, that vitamin D binding protein, and then this goes into the kidney, and then that regulation happens at that level in the kidney, and then able to be changed into that calcitriol form. This form is highly regulated, and the parathyroid hormone is the one thing that regulates this. And I do want to point out that this form, the 25 OHD form, is how our body keeps it. But if we need the calcitriol, then it just goes into the kidneys, and then we make this form. So then this form is our functional form. It goes out into the blood and other body tissues. Dun, dun, dun. Kind of scary, but it's going to be easy by the time that this is over. So the main function of vitamin D is to maintain serum calcium levels so that those serum calcium levels are always staying consistent. So kind of three sub-functions of that maintaining the serum calcium levels. We first regulate intestinal calcium absorption, we regulate calcium absorption in the kidneys, and regulate calcium absorption from the bone. So now let's look at this whole thing. So when we have low serum calcium, low calcium in our blood, it signals to our parathyroid glands, which releases parathyroid hormone through that activation of the calcium sensing receptors. So parathyroid hormone is increased, it is increased in the blood and goes into the kidneys, which causes the kidneys to increase their calcium reabsorption. So with that, increases calcium reabsorption in the blood, and so increases that blood calcium. In the kidneys, it also stimulates renal hydroxylase, which is also 1-hydroxylase, to convert that 25-OHD to that calcitriol main form. So in that main form, it's also able to increase the blood levels of calcitriol, and so it increases the dietary calcium in the lumen of the gut. So you have more blood calcium, increased blood calcium, increased blood calcium. This calcitriol, the increased calcitriol stimulates calcium absorption in the intestines. So that's the kidneys, that's the intestines. Actually, I am messing it up. I do want to mention one more thing with the kidneys. So this renal synthesis of calcitriol is regulated by 2 hormones. One, obviously, is this parathyroid hormone, and then the other is called fibroblast-like growth factor, so FGF23. And it's secreted by our osteocytes and osteoblasts and regulates the activation of vitamin D3. So, want to point out that parathyroid hormone stimulates the synthesis of 1-hydroxylase, so what's able to convert these things. And the FGF23 reduces the synthesis of 1-hydrolase. So, this is so we're not completely breaking down our bones, and we get those, specifically the FGF23 from our bones, but it's so we don't completely break down our bones, and just also want to mention that calcitonin works against that parathyroid hormone. I didn't mention the bones yet, but I kind of was alluding to it with that hormone that helps regulate the hydrolysis stuff. But we have the increased parathyroid hormone, which results in increased calcitriol traveling to the bone. When we have increased parathyroid hormone and calcitriol, we stimulate resorption, and this is not reabsorption, it's resorption of calcium from bone. So what this is saying is basically it's so important to keep those calcium levels normal. We do not want them low. So it's so important that the integrity of the bone would rather be lost to release that calcium into the blood than to have the low levels of calcium. But again, we do have those, that FGF23, which reduces the synthesis of that 1-hydroxylase. So we're not completely breaking down our bones. And then, okay, so overall, we have low serum calcium. It sends a signal to the parathyroid gland, which makes parathyroid hormone. Parathyroid hormone is released. The kidneys increase the expression of the enzyme. Vitamin D is released in the calcitriol form, is released from the kidneys, and increase absorption of calcium both in the kidneys and in the intestines. And in the bone, it causes resorption of bone. Now it does have gene functions. So vitamin D increases the absorption of calcium through regulation of genes involved in the transport. So if you remember back to vitamin A, it had something called RARE. It functions like a transcription factor, but this is vitamin D response element. So we're able to have these different guys that are able to use the calcitriol or vitamin D, and it can regulate specific genes as it's incorporated into the DNA. So it regulates proteins at a genomic level. And then what else? It increases the calcium transporter in our intestines and our kidneys so that we increase calcium, and that's how we actually get vitamin D into our system. So very important, and I think it is really neat that the foods we eat, specifically with vitamin D and vitamin A, directly relate to gene expression that we can see in our DNA here. Vitamin D also does have non-genomic functions, so calcitriol can bind to receptors located on the cell membrane, and it's able to signal inside of the cell through second messenger pathways. Some of those inside the cell functions are calcitropic, immunomodulatory, antiproliferative, and pregnancy-related effects. We can evaluate our vitamin D status by looking at the 25 OHD. So like right before it gets into the calcitriol form, it when it's in like the liver, that is how we can see, because we store it at that in that or I guess not really store it, but we keep it in that function, we keep it in that form. So that's a good way to evaluate our vitamin D status. And then also I want to point out that our skin does contribute to vitamin D. So if you live near the equator, you have better vitamin D synthesis because you have more exposure to the sun and longer exposure to the sun. But also if you have very dark skin, our body does not regulate the same amount of vitamin D. So it is important to take those factors into consideration. Now, what happens if I don't have enough? Two things happen specifically in children and older adults. So in children, we see rickets, so that affects our long bones. They're not able to mineralize properly, kind of get like bendy. Also see seizures, growth retardation, and failure of that bone to mineralize. And in older adults, we have osteomalacia, so a bone mineralization defect, and remineralization cannot occur. So people at risk for osteomalacia include the elderly, if you have insufficient sun exposure, and populations with defects that may affect fat absorption, and even infants that are exclusively breastfed can have a risk of not enough vitamin D. With the osteomalacia, I also want to mention that is where the spongy form of the bone demineralizes because of that loss of calcium because it's trying to compensate for the low serum calcium levels, because vitamin D is not doing its job of regulating the serum calcium levels. So vitamin D also, on the other side of the spectrum, is our most toxic vitamin of all the vitamins. It actually can do the reverse. If we have too much vitamin D, it can lead to calcifications in our kidneys, heart, lungs, blood, etc. It can affect our bone health in the opposite way. Or, no, that's not what I meant to say. So if we do have enough vitamin D, then we are benefiting from bone health. We also, there has been some link to vitamin D and diabetes, so it's connected to insulin secretion and improved insulin secretion response. We also see it in neurological health, specifically in multiple sclerosis. Now, I want to just mention really quickly, many things are fortified with vitamin D, and we have the sun, we have all these things, and yet we still have so many people who are deficient in vitamin D. So there is a disconnect somewhere. So as the dietitian, we can work to figure out where that disconnect is. If you found this video helpful, please like and subscribe, and join me next time. Thanks.